Hello there, I'm Thomas Hatsios, the German-American pilot flying the Boeing 787 909 flight. We're going to be able to find Zurich on German, the coming back to the Zurich International Airport runway 14. Hello there, I'm Thomas Hatsios, the German-American pilot flying the Boeing 787 909 flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport runway 14 for an ILS localized landing. So we're going to be overflying my home, not Germany. You know, I love it. So I'm going to show you the cockpit instruments, displays, and functions of the Boeing 787-908 jet aircraft. I'm using the quality wings Boeing 787-900 and the micro-supplies simulator X. I'm going to show you all the systems, including the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot and flight director system panel, the ground speed, the radio altitude above the ground level, the magnetic heading and track, the magnetic north pole and true north pole, the magnetic variation depending on where we are in the world. We have also the altitude, the barometric altitude above the sea level, the altitude selected from the autopilot and director system panel, the barometric pressure of the outside atmosphere, the rate of climb descent of the aircraft in tens, hundreds, and thousands of feet per minute. That also displays the trigonometry, the stiffness of the trigonometric angles in decreasing and climate descent. Also, we have the altitude indicator with the artificial horizon, the pitch ladder in degrees, and the bank angle in degrees. Also, you can see the ILS localizer, the frequency of the ILS localizer, and the name, uh, the code name of the ILS localizer. Also, we have the ILS localizer horizontal uh, and the vertical glide slope needles, and the ILS localizer crossbars from guidance to the destination runway, vertical and horizontal. So I will explain also that. We have also the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. So we have also the angle of attack of the aircraft and the flight mode annunciator, the autopilot and the auto throttle. Later on vertical navigation modes. I'm gonna show you also the you're gonna see other systems. You're gonna see um so we're gonna have also the navigation display. The navigation display that displays the inertial reference, the GPS position of the aircraft. You can see the terrain and weather reflections from the weather radar, the terrain map, the elevation of the terrain around you displayed with red, green, and yellow colors. Also, the sea, the lakes, and the rivers with blue. We have the display of the airports in the terrain map. You can see where they are located, also using the GPS location. So we have also the magnetic north pole and true north pole and magnetic variation depending on where we are in the world. We have also other aircraft that fly around our own aircraft. You can see them displayed using the transporter ADSP and ADC transmitter receiver that transmits our frequency to other aircraft in the air traffic control and also receives from other aircraft and the air traffic and displays the other aircraft in a diamond shape. Their distance from our own aircraft, bearing altitude difference, whether they climb the descent, and this also calculates their airspeed. So we can generate the TICA system, the traffic collision and advisory system, so you can see the traffic warnings. Also, we have the display of the airports, the waypoints, navigation fixes, waypoints, horizontal, vertical navigation fixes we have to fly the aircraft through, the road station, the ADX, the MDPs. So I will explain you all the function of all these systems. We have also we're gonna use the flight management computer. I did that already. The left and the right flight management computer and created a flight plan or a flight path or a complete route for the aircraft from takeoff, climb, cruise, descent, approach, and landing. So I will input all the data of the aircraft for this flight. That includes the takeoff gross weight, that includes the empty weight plus the passenger plus the cargo plus the fuel on board. That includes the trip fuel, the reserve fuel, and the cargo fuel. So we're gonna have the calculations about the mean aerodynamic chord position of the forward wings. Um, that is the position where the maximum aerodynamic lift occurs in the forward wings. Also the position where the stall begins. It's also the position where we position the center of gravity of the aircraft approximately the other axis versus the longitudinal axis of the aircraft. Also we use for calculations of the horizontal tail of the aircraft stabilizer trim, for trim down, so you're gonna see also that we can trim the horizontal tail of the aircraft manually using the trim switch in the control wheel in the yoke of the Boeing 777 or 787 or any Boeing aircraft, or automatically using the autopilot flight director system to give the commands about the horizontal trim stabilizer in flight from takeoff, climb, cruise, descent, and approach. So right now we have around 4.25 degrees. We're gonna use 15 degrees of flaps. We're gonna select this runway for takeoff. The runway length, the runway slope, the runway conditions, if it is ice, dry or wet, the wind direction and speed, the barometric pressure, the density of the air and the temperature of the air. So this is gonna give us the takeoff speeds, the V1, V rotate, and the V2, which is the takeoff speed. So you will see them how we calculate them automatically using the flight management computer. Also, we're gonna insert and create a complete flight plan or flight path or route. We have done all this already, so you can see the route here displayed with this purple line over here. So you can see we have a route created here, and we have to follow this flight plan line from takeoff, climb, cruise, descent, approach, and landing as we fly. And we're gonna follow the flight director here. Also, you can see the vertical flight path over here as we climb, then cruise, descent. We're gonna have also the altitude constraint. You can see also other information, the terrain, the airport, horizontal and vertical navigation. So we have also the elevation of the airport here, the airspeed indicated, the airspeed selected, the altitude selected in the primary flight display, the flight director. So this is a navigation display. This is the flight management computers here. You can see them. We have created the flight plans, so they display now. The overhead panel also, I will explain you later. So we have the control here. The flight management computers, which are a new kind of flight management computer. The left and right. So we have the route here, the performance here. Also we need to use 15 degrees flaps, and this will give a calculation about the center of gravity here. As I told you, center of gravity 33% and 4.35%. The trim stabilizer, 15 degrees of flaps, and this gives us a takeoff speed over here, V1, V rotate, and V2 for this gross weight. And we have it here in the virtual cockpit. So we have the route, the flight plan here. We have the legs here created. So this is gonna be from takeoff all the way up the climb. Next page. We're gonna climb and cruise over here, then return back for landing through these waypoints. Over here, this is the final approach fixes and the runway elevation. So we start here from this point, and you will see all this happening later. So I will show you also all these things, the complete route of flight plan of flight path. So we insert This is the other instrument departure and waypoints, which include the horizontal and vertical navigation fixes for the initial climb and takeoff of the aircraft from this runway, climb and cruise intermediate waypoints, and the destination airport. In runway, we have the descent and approach waypoints and fixes, horizontal and vertical. Also, we have constraints, altitude and airspeed constraints. So we have the approach, the stars, the southern terminal arrival waypoints and fixes for the destination airport and runway, which is for the final approach. Also we have the Lszh localizer tuned for the runway for this airport. So we're gonna use the same airport for departure and for approach. So we're gonna have the Lszh localizer tuned automatically using the flight management computer, or we can tune it manually using the radio management panel. So we have the Lszh localizer, the vertical glide slope, and the horizontal localizer needles and the crossbars, which will help us to align and guide the aircraft horizontally and vertically in the runway for landing. And this also we're going to have the magnetic heading set in the autopilot flight director system panel of the runway we're going to use for takeoff and landing. So this will help us to align also the runway in the Lszh localizer and the instrument landing system of the airport runway. So we have also after that I will show you the autopilot system. The autopilot engages and disengages switch, the autothrottle left and autothrottle right engage and disengage switch, the flight director engage and disengage switch. We have the airspeed select knob. You can select an airspeed, nautical miles, knots, or Mach speed. So this will set the airspeed guidance of the aircraft and will command the engines. We have the GNX engines installed in our Boeing 787-900, one on the left and one on the right wing. For symmetrical thrust and retardancies, one contains a FAREX, the full authority electronic control computers, one installed branch gearbox, commands the engines indication and function. You see in the upper and the lower ACAS and indication control system display or function display. So we have when we set the airspeed here, selecting the autopilot and flight director system panel, we set the airspeed, the flight director, autopilot, and auto throttle engages. Engage the LNAV and the VNAV, which are interconnected here with the flight management computer. Later on vertical navigation modes, the heading of the runway, the bank angle, the vertical rate of climb and descent of the aircraft, 10,000 feet per minute. So autopilot engage, disengage, vertical rate of climb or descent, and flight path angle, trigonometric angles increasing and climb and descent. So you will see this happening here in the vertical speed indicator, or you can see how steep the aircraft climbs and descends here. And also the altitude, select the altitude, hold the VOR localizer for the Lszh localizer approach, and the autoland switch for the autoland function of the Boeing 787-900. So you will see we select the airspeed guidance commands, the FAREX of the engines. We have the thrust levers here of the engines. Also we have the thrust reversers. We have the flaps here. You can set the flaps, not related to the engines, but you can extend fully. We have the thrust levers like this, forward and aft, and the auto throttle here, disconnect the switch, and also the takeoff go around switch. We have the fuel flow to the left and right engine, and now the fire extinguishers for the left and the right engine. You can pull out and switch. So this cut out the fuel flow to the engine and shut down the engines. Also we have the auto start here for the left and the right engine, the electronic engine control for the engines, normal and alternate mode. So I will show you how we're gonna start the APU, the batteries, the bleeder from the APU, and the fuel system, and we're gonna use the auto start to start the engines. Later also the fuel control. You can see also we have other things. We have the speed brakes here, up and down, extend and retract. You can see the speed brakes like this, extend and retract. So this extends and retracts the speed brakes of the aircraft. The smoke handle like this. Also, we have the flaps here set all the way down like this, using this handle here, which extends and retracts the flaps. So we have also the horizontal trim stabilizer here, normal and cut out on this control guarded. So it's if we have a failure of the auto trim, we'll have to disconnect from the autopilot and the auto throttle. If we have a failure of the hydraulic system, so I will show you. We have to disconnect and use only the manual trim from this stub. This is the trim of the horizontal tail that I explained already. Trim up and trim down the horizontal tail of the aircraft as it fly. The whole surface, not just the elevator. You see I move right now up and down. So you see the tail like this of the aircraft moving in total later. So you use this trim tab here. So you use this trim tab, pitch up and pitch down. Also use, I will show you the flight controls after that. Climb descent. So we have also the thrust levers. When you give a command to the engine's thrust, the airspeed guidance, this commands the engine's thrust rating, the N1. I will show you the N1. We have the low speed starter, the full pressure, compressor, and turbine with the turbo fan, which is engine. The exhaust gas temperature per engine. This commands the FAREX, the full authority's electronic control computers. As I told you, one installed per engine gearbox, Flught channel redundancy, one channel phase out control module, display all the functions. Fuel flow per engine per hour, 1000 kilograms, 1000 pounds. The N2, which is the high speed starter, the high pressure compression turbine of the turbo fan, which is engine. Oil pressure, oil temperature, oil quantity, and the vibration of the input stages of the engine. Also, engine fuel flow to the engines, engine start, engine shutdown, failures of the engines, other sensors like fuel heat exchange heater and fuel mixture. As we climb the descent, we change the pressure and the temperature of the air and the intake rate of air from the front fan of the engine. So we need different fuel mixture requests every second, so this is done automatically using the FAREX. So this commands also the thrust levers position here, or you can request a manual or automatic thrust setting. So we have the flight directors on right now for the takeoff go around. As you can see here, the rating here of the engines, the N1, which is the low speed starter and shaft and low pressure compression into one of the turbofan puts the engine, the left engine and the right engine. 30.6% idle now on maximum takeoff 100.8. The green, red and yellow limit the exhaust gas temperature per engine. The N2, which is the high speed starter and shaft, the high pressure compressor and turbine of the turbofan puts the engine. The fuel flow per engine per hour, 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, vibration of the N2 stage of the engine. You can see also other information here displayed, like other systems, FMC, TCAS, parking brakes, the landing gear here up and down, the auto brake, alternate gear, the horizontal trim stabilizer and the rudder trim, the flaps set here that I show you. When you set the flaps here up and down, it will display the position you have requested. So we have also gross weight in thousands of pounds, fuel temperature and total fuel on board the aircraft also displayed. So I will show you all the functions. I will now go for I show you also the thrust levers. You move forward the thrust levers, you see the commanded here thrust requests using the thrust levers. It takes a couple of seconds, so you have to anticipate that in flight when you move forward and after the thrust levers for engine thrust. Also when you use, as I told you, the airspeed guidance. The airspeed guidance has two main modes. You can use On the fixed thrust mode, when you climb and descend the aircraft, you have maximum continuous thrust for climb or idle thrust for descent. So the airspeed of the aircraft will be adjusted as you climb or descend by how fast the aircraft will climb and descend. The horizontal trim stabilizer position, trim up and trim down on the elevator of the horizontal tail of the aircraft. Position either automatically or manually. Also, when you cruise the aircraft horizontally or you approach and landing, you have the variable thrust mode in which the airspeed is been adjusted by varying the thrust commanded by the engines. Also, other systems we have, I told you, thrust, speed rigs, the flight controls. Maybe I will show you the flight controls of the aircraft now. So we have here the flight controls of the aircraft. So you will see how we use all the speed brake for how we use this side stick actually. So we'll show you now the horizontal trim stabilizer and also the horizontal tail and other functions. Wait, perhaps we need to use also that. So I'm gonna show you now. The flight controls of the aircraft. I use this side stick here to control the control column and the control wheel of the aircraft for moving up and moving down. It's down the horizontal tail of the aircraft, the elevator, and also making bank rolls left and right using the control wheel, and also the rudder pedals for the vertical tail rudder for yawing the aircraft. Also using the horizontal the rudder pedals for toe brakes and for the nose wheel steering in the ground when they are interconnected before reaching some certain airspeed. So I'm gonna show you now the flight controls, and I will show you the overhead panel and make the engine start demonstrations. So we have here so you can see here we have the flight controls, the side stick here. We can climb and we can descend the aircraft like this. So you can see it's moving. Both flight controls yokes like this, moving forward and moving aft. Also we have the horizontal trim stabilizer, so you can climb and you can descend the aircraft. Also you can make turns to the left and turns to the right, turns left and turns right. I hope you see it better now. So climb and descend. Also the rudder pedals for right and left yoke. So you can see both sides are interconnected when you move the side stick or the yoke. The first officer and the captain. Also the rudder pedals are interconnected, and you have also the nose wheel steering when the parking brakes are off and you move the aircraft. So you can use the horizontal trim. You can use also the thrust levers like this. And the thrust levers forward or aft will increase and decrease the thrust commanded by the engines like this. So you can use the thrust levers, and you can climb, you can descend the same way, the same moment you use all of the flight controls. You can see the side deflection is proportional to the yoke deflection. So now we'll show you a little bit of the outside view of how you use the flight controls for moving, how you use the side stick for moving the yoke and the flight controls of the aircraft of the Boeing 787-900. So we go now here in the outside view. So you can see again we can climb and we can descend like this. Also use the tail, the rudder, and also making turns left and right. So this how make turns. Also the tail, climb and descend. So you can see how quick the response is to that. As we fly the aircraft. So we can also leave neutral, and we have, as I told you, horizontal trim stabilizer. So this is all for the flight controls now, as you can see. Now we'll show you the overhead panel systems, also the displays, the system displays. I will show you in the overhead panel. We have the electrical system, the left and the right engine. I see the great drive generator from the left and the right engine that produce 120 200 volts alternate current, 120,000 kilovolts is left and right engine, and the APU also. The battery is the primary and the standby. The APU will need the smaller turbine in the tail of the aircraft to start the engines in the ground. We're going to be mechanical and dark start. This provides alternate current and pressurizer for that admits the pressurizer into the engine starters. I would say also the hydraulic pumps, the left and the right engine driving the electric C1 and C2, which are also pressurized. I will show you other systems, the rammer turbine, the passenger oxygen, the window heat, the fire extinguishers, the electronic engine control for the engines, the fuel system, the left, the right wing and the center tank and the fuel booster pumps, the crossfeed valve, the wing and engine anti-ice, the air condition, the cabin pressurization, also the bleeder from the left and right engine, from the APU. We need to start the engines, and from the left and the right engine we need for hydraulic fluid pressurization, wing and engine anti-ice, air conditioning, ventilation, also for cabin pressurization. We climb at the same. So I'll start now showing all the systems. So thank you very much for joining this video. I'm Thomas Hatsios, the British America Power Time Boeing 787 909 flight. So I'll start now. So stay tuned until after doing the engine start demonstration. We have the complete flight of the aircraft from takeoff, climb, cruise, descent, and approach. You will see me flying manually this aircraft in the end part of the video. So stay tuned until then, like 10 minutes from now. So I'll see you again. So we start now. We have a couple more things to see. So you can see all the displays here again. A nice view, relaxing from around the airport right now. We have also another aircraft coming in for landing. So maybe we can spot that in the navigation display as a traffic, but so we have here you can see the airport here displayed. So here we have the aircraft here coming in for landing. So you can see here the airport, you can see the runway, We have the one we're gonna use for takeoff, the one beside us. Over here, the terrain, the steepness. Over here we have to use for climb. So we use also closer range. You're gonna see more of the runway here. Also the runway in front of us, the taxiway. This is the closest one we can have. The position of the aircraft, our own aircraft symbol right now. So you can see all these runways here. So we have also the flight plan we have to follow, from climb, cruise, also here vertically, the flight level, then approach and landing. We have the airspeed here, the primary flight display, the airspeed selected, the parametric altitude, the altitude selected, the pitch ladder in degrees. You can see how many degrees we have here. For pitch like 2.5, 5, 7.5, 10, 12.5, 15, 7.5, 20 for climb and descent. Barometric pressure, radio altitude above the ground level. Also, some codes we have here. So we have we're gonna use this airspeed now. Flight level change. We can disarm actually. Flight level change we don't need, because it gave us a lower airspeed than the one we desire to have. Also, here the heading, bank angle limit, and we're gonna use the heading of the runway. We're gonna have for takeoff like this, like 136 degrees. Also the altitude here can change. And the vertical speed, perhaps we can set also that for let's say a climb or a descent. So we're gonna use it for a climb like this. I will display a climb, as you can see. So now we have different modes indicated here. Also we have the head-up display here. So we'll show you also the overhead panel if we have some time. So we have the airspeed, the altitude, all the information now. Different airspeed, different altitude. We need to use this also now. The overhead panel. Also you have to start the APU. You can see the left and the right engine. I integrate drive generator, the APU, the battery. I'm gonna start the APU now. You can see the fault display. The primary flight control computer is here on auto. The heading reference and the RS inertial reference system. The flight control surfaces. We need the hydraulics also. Here, hydraulic pumps off or on. Also this you can turn on or off, like this. You will be see the fault message. So we have also the lighting system of the aircraft, the windshield wipers, the passenger oxygen, the rammer turbine, the window heat, some other systems, the fire extinguishers for the cargo and the APU, the electronic engine control with the auto start. Here we're gonna use the auto start later. You will see fuel jettison, nozzle, select nozzle and arm. fuel crossfeed balance if we need. So this is the fuel system. Wing and edging RDIs here on or auto. Also the cabin pressurization. You can use manual, use the outflow valves when climb and descend. Select landing LD, we use auto, and we have the pressurizer from the left and right engine. So this is the main overview of the overhead panel. We have also this view of the overhead panel here with all the systems. As I showed you, electric, hydraulic, rammer turbine, electronic engine control for the engine, fuel system, left and right wing, fuel tank, center tank, fuel jettison, wing and engine RDIs, cabin pressurization, and pressurizer system from the engines and also from the APU. So we go now here in the virtual cockpit. Also, it's just the last thing before starting the engines. We have the systems here displayed. So you will see like in the Boeing 777 hydraulic, APUs running, oxygen, liquid, cooling, electric, left and right engine, the great dry generator, alternating current, 130 to 200 volts, at the APUs running, 130,000 kV for 100 Hz frequency, main battery, direct current also. Lszh, hydraulics, left and right engine, C1, C2 electric, hydraulic pumps, also where the hydraulic fluid goes, systems use it, fuel system, left and right wing, fuel tank. You can see crossfeed is closed, center tank, how much fuel you have in its tank, total fuel 33.7 thousand pounds. Low and high pressure fuel valves to the left and right engine on, feed the engines, fuel booster pumps forward and aft on. The APU is fed from the left wing using the DC motor. Also the minimum fuel temperature below which the fuel freezes. Also we have the crossfeed to feed either engine with either pump or either tank. The air system, left and right engine, the APU also. The doors are closed, the cabin can be pressurized, the landing gear, you can see the temperature of the brakes and the pressure of the tires, flight controls. You can move over the flight control surfaces like this and see them moving. Also the stabilizer trim of the aircraft here, the FS maintenance system menu. So we have also the checklist here, normal menu, presets, normal communication, just like in the so we go back to the systems, navigation display. So we're gonna start the engines now. We can turn off both engines using this the fuel cutout switch. So we're gonna have the engines off. Also use some light here. So you see both engines, exhaust gas temperature, and one is decreasing. So we'll shut down both engines. You can see both right and left wing. There is no pressure right now. We have to use the auto start and then use the fuel control. So we can use both left and right. Auto start on. You will see some reconfiguration is happening to the aircraft. So gonna have the N1, the exhaust gas temperature, the N2 also. So you're gonna see the auto start after you reach some level. So we're gonna let the fuel control on. We're gonna have the auto start now. Over here you can see auto start both engines. You can see them also outside, the right and the left engine spinning up. So we have the auto start to keep going. Auto start. N1 above 14%, 15, 60% the N2, and we have the engines running now. So we can go for takeoff like this. We have both engines running. So we're ready to taxi and take off. So we have the aircraft ready for taxi and for takeoff, and we advance the thrust levers like this, parking brakes off, also the flap set for takeoff like this. So we advance the thrust and taxi into the parking into the runway. So we have taken the clearance from the air traffic control here. So the runway is open plus. So we are aligned, thus having a nicer view from here, as you can see, as we're gonna take off now. So we're gonna have this view for takeoff, maybe. So we advance the thrust levers forward, and we have directors off, so parking brakes off also. So we have 70 knots, 80, align with the rudder pedals now, 100 V1, we rotate, here we go, pitching up slightly, as you can see. So keep pitching up, and we have the positive rate of climb. Landing gear up, retract, so we are 1100, 200 feet above the ground level. You can see the airspeed here, the stall speed, all the indications. We have the flight plan here, also the ground. So we are 1700 feet, 1800 above the ground, 2000 feet above the ground, 3000 feet to 3900 above the sea level. We climb this rate of climb. So the airspeed, stall speed, and also the trend. Here you can see as the altitude or the airspeed increase and decrease. Also the vectors here, you can see the terrain below us. Some ground that we have displayed also. You can see how far away we are from the ground, like this. We keep climbing. You can see also the navigation display, and we have here the aircraft is after takeoff from the runway. Keep climbing. Gonna have a better view now in a second. So now we need to go inside for the climb here. We're gonna make a turn. Also use more thrust, more airspeed. Also climbing. $8,000. So we keep climbing. So here a nicer view of the Boeing 787, the 900 model, also the galaxy view. You can see the whole of Switzerland here, the lakes, the city. Also the Boeing model here, closer view as we climb. You can see we're flying with this like 250 meters per second now, the airspeed of the aircraft. Also nicer view of the Boeing 787. As we keep climbing, so can have also we're gonna have the Germany and the France this way. So we're going back inside, I believe, to see the rest of the flight. $16,000. So we're gonna have flight route 16,000 now, 165, 66 knots. We have the flight directors on now. That's the display. So we cross now the first waypoint here, the Zui, 2 nautical miles. I'm gonna intercept I will keep climbing. You can see also here and we have like 30 more minutes for this flight to end. So this is the whole aircraft now, all the indications we have, also the thrust we use right now, 100.2, have the cruise through here, 30,000, keep climbing. So we have also the lake here, it's a beautiful lake, and the Switzerland, and we have the Germany in front of us, the Bayern Munich, and the France in this side. So we have also the galaxy. So this is our spacecraft at night, the Boeing 787 900. So the beautiful lake here. So keep climbing. We need to accelerate a little bit, so maybe we're gonna level off for a while and accelerate, retract some flaps perhaps. So this is the acceleration now, 32,000, 3, 170, max 0.4 as you can see here, max 0.412. We have to fly through these waypoints here as you can see, and we have the flight management computer also. Keep accelerating, 33,000. We have more of a stall speed now, 34,000. And we're gonna cross this to 27,000 feet and lose time now. So we are here at 35, 34,000. You're gonna see cruising manually for a while. Reach flight level 250, and we have to level off now. So we're going manually now with my own commands, 35,300 feet and about Mach 0.4 or 500 kilometers an hour with the 787. Now we're gonna climb higher, that's for increasing the airspeed and the altitude. Also the altitude, like 39,000 over here. So keep climbing for a while. We're gonna have a few more minutes to go like this. 36,000, 0.4. We're gonna start having some handrails in a while, so maybe climb a bit higher. So we're gonna have the handrails now, 37,200, 3, 4, 4, 5. Still not have them. 700. Here we have the handrail, 37,700 feet for this aircraft. So we have this beautiful display of the handrails, the frozen vapors, as you can see, and overflying the lake here. And the Germany, the Bayern Munich in front of us, the France, and the galaxy view. So we need to start making the turn now. Hope you like the view of the chemtrails, frozen vapors. So we have like 14 more minutes to go like this. So maybe we're gonna start making the turn now. Here we are making the turn with the point, and we need also to retract the flaps now fully and accelerate to a higher airspeed as we go like this. You're gonna see accelerating maybe Mach 0.9. So here we are, we're taking the turn now. We're going back home, across through the lake and the Bayern Munich here. And we have 39,400 feet. We need to descend a little bit. And we're going for the lake now, and the Switzerland also. So we are at 30,000 feet now. We can cruise here if we like. 30,000. This is 30,000. And maybe the autopilot 31,000. Mach 0.5, so we're gonna be accelerating, and we have like 11 more minutes to go, as you can see. So we need to start descending now into the airport, while we keep having all these beautiful chemtrails. So we are 30,000 now feet, as you can see. 30,700, 600. And we need 10 more minutes to go, so we can also connect the autopilot with the LNAV also function if we need to close here. And we have max 0.78, very high max speed. We can descend also. 39,000, max 0.8 to 8, keep fine. Higher max speed now, and we have the frozen vapors here and the galaxy view of the aircraft, as you can see. So we keep having chemtrails, quite many of them, and we fly with about max 0.9 right now, so we have higher airspeed. So we need also to start descending now to the airport. We have like 10 more minutes to go, with cruising with about 0.9 Mach right now. So you can see also these beautiful chemtrails now we have. And this is the spacecraft view of the Boeing 787 tonight from overflying Switzerland and going back home. So we need to start also descent. So select lower altitude. Vertical speed also. and the Mach speed also decreased a little bit now as we descend. We need to use also some speed brakes, slow down the aircraft. And we have like 7 more minutes for the end part of the flight as we descend to the final flight path here waypoints. We need to cruise and descend now to decrease the airspeed. So we keep descending. We need to decrease the airspeed now. We keep flying manually. So we are in approach now for the landing. There's also some flaps. We have us decrease the airspeed. And we're going in for landing, and we have like 3 more minutes left. Advance the thrust levers, and the runway is thus a little bit behind us. As you can see, we need to align here with the Lszh localizer. We are almost perfectly aligned. And we have like 3 more minutes to go. So we are here, we are approaching for the landing. We have the Lszh localizer over here and the flap set. So we are here. Just touchdown. Parking brakes and reverse thrust, full reverse. And align with the center line. Here we are, just landed very nicely. Here you can see where we are. You can see the landing gear behind. All the wheels and the tires are perfectly safe. Also the forward tires and wheels. There is no breakage of any part. So the aircraft is starting up. The weight should be in its wheels and the metal part of the screws of the landing gear here behind, and the front wheel. As you can see, all parts landing gear is safe. So you see also the cockpit. So that was Thomas Hatsios, the British American pilot flying the Boeing 787-900 tonight's flight with us.